Hi guys, this is Engineer HB and welcome back to Derive. So in today's video, we're going to discuss this chapter 13 of our machine design, which is about belts. And kagaya na kagawian, before we proceed to answer those past board exam problems, review muna tayo ng mga formulas, of course. Okay, so let us proceed. So ano muna nga ba ang definition ng belt? Sabi, a belt is a loop of flexible material used to link two or more rotating shafts. Actually, si belt ay member ng tinatawag na FPTE. Wait lang, hanap lang yung tinta. Yan. So, under siya ng FPTE. So, what is that FPTE? So, that was a flexible power transmitting element such as, yan nga, belts, chains, pati na rin yung wire rope, and etc. So, siya ay isang flexible power transmitting element. So, kagaya ng mga nasa picture, so ginagamit siya para mag-transfer from power, ng power from one point to another or from one body to another. So, there are two arrangement of belts, which is the open belt and the closed belt. And sa picture pa lang mahalata mo na mayroon talaga silang pinagkaiba geometrically, no, sa shape ng arrangement ng belt. So, this open, so yan yung open belt. And dito naman is yung closed belt. So, obviously, yung pinaka-belt niya, yung line na yan, makikita natin na mas mahaba yung mako-consume na belt given to same center distance dito sa closed belt arrangement. Okay? So, ayan yung the two pictures of arrangements of belt. So, of course, discuss natin mga formulas. First muna sa open belt arrangement. So yung bigay lang natin yung mga parameters na yan kung ano-ano yan. So of course yung D, syempre nire-represent niyan yung diameter. So syempre yung maliit, sabihin na nating first pulley at itong malaking bilog is the second pulley. And capital D represents of course the diameter and represents the RPM or the rotational speed of the pulley. And of course, this theta is the angle of contact. Yan yung theta 1 and theta 2. Ano pa ba? And of course, yung letter C is the center to center distance. So dito na lang siguro. Center to center distance. So those are the letters that will represent the diameter, RPM, angle of contact, center to center distance, and etc. So ano nga muna ba? Itong angle alpha shows the formula of arc sine, the difference of the two diameters of the pulley over the 2 over 2 multiplied by the center distance. And of course, this angle of contact ay magkaiba sa both pulleys. So sa theta 1, itong sa maliit na pulley, that was 180 degrees minus 2 alpha. So if you are going to get this alpha, kunyari 10 degrees yan. So of course, ibig sabihin ng angle of contact mo sa maliit na pulley is 180 degrees minus 2 times 10 which is 20 degrees. So that was 160 degrees. Okay? Kung makuha mo naman dito, at kung tinatanong naman is angle of contact nung larger pulley, of course, that will be 180 plus 2 times 10. So that was 200 degrees. And obviously, makikita mo naman, yung angle of contact talaga ng larger pulley is greater than the angle of contact of the smaller pulley. And syempre, 180 degrees na yan. Syempre, isang diretso yan. Magpalit lang ako ng red. Yan. Syempre, ito is 180 degrees. At syempre, ito yung alpha natin. So, bawas mo yung dalawang alpha na yan sa 180 degrees. Of course, that will be your theta 1. And itong alpha na yan, of course, same yan dito. And this formula were derived from that. Tapos, ito naman, of course, halata naman na ito yung 180 degrees nung larger pulley. And of course, this is your sine alpha. So the angle of contact of your larger diameter will be 180. Ayan, plus twice nung alpha. Which is ito yan. Okay. So how about the length of belt? So the length of belt of course is pinakabida ito sa topic ng belt. Kasi syempre sa design ng belt, kailangan malaman mo rin kung ano yung total length of belt. So ano-anong kakailanganin natin sa length of belt? So we're going to need the two diameters of the two pulleys. Of the diameter of the two pulleys, of course, the letter C, which is the center to center distance. So yan lang naman kasi ito letter D din and letter C. So that will be the length of belt is pi over 2 multiplied by the sum of the two diameters plus twice ng center distance and plus the square of the difference of the two diameters over 4 multiplied by the center distance. And I know all of us are already alam na natin to lahat. Siguro konting review lang at konting memorize, ulit-ulitin mo lang sa papel and makakabisa mo uli ito. So madali lang naman dito sa una, pi over 2 times d1 plus d2. Second term is yung twice mo daw yung center distance. And of course, ito naman is square mo yung difference ng two diameters over 4c. And of course, we have the velocity of belt is equal to pi dn. Pwede ring 2 pi rn, pero pwede ring pi dn. And of course, the velocity of each pulley is the same. Kung ano yung velocity ng smaller, that will be the velocity of your larger pulley. And in short, that was pi d1 and 1 is equal to pi d2 and 2. Of course, pi will be eliminated. That will become d1 and 1 is equal to d2 and 2. So that was the relationship of their diameters and speed. Okay? Of course, dako tayo sa closed belt arrangement. Kanina nga, as I said earlier, obviously mas mahaba yung belt niya kasi sa open, 'di ba? Ano siya, parallel halos eh. Ito cross nag-intersect. So ibig sabihin may certain amount that is larger than the total length of the belt of the open belt arrangement. So same pa rin naman. Ayan yung diameter represented by D. Speed represented by N. Of course, the angle of contact represented by theta. And of course, this alpha. So magkakaroon lang tayo ng konting adjustment sa formula since this is a closed belt and the length of belt is larger than the open. So yung alpha kanina sa open is D2 minus D1 over 2C. So, or rather, arc sine of D2 minus D1 over 2C, dito naman sa closed belt, gagawin mo lang siyang plus. And sa angle of contact naman, parehas sila, which is 180 plus 2 alpha for both angle of contact ng small and diameter pulley. At makikita mo naman sa figure na talagang same sila. So they are both larger than 180 degrees. Unlike sa open, ang smaller pulley is 180 minus 2 alpha at si larger naman is 180 plus 2 alpha. So dito naman sa closed belt, that will be equal. So sa length of belt naman, same lang guys. Ang pinagkaiba lang is yung dulo mo, which is sa open ay naka-minus to. Dito naman is naka-plus. So tandaan mo lang yung mga formulas talaga sa open at konting adjustment lang sa close and goods ka na sa formula niya. So velocity of belt, same pa rin naman. Velocity is equal to both sides. So that will become D1 and 1 is equal to D2 and 2. So sa belt tension ratio naman, syempre, kagaya ng chapter 3 natin na shop, lagi namang may belt tension ratio kasi may tension yung belt dun sa scenario or dun sa case na pinakita natin sa mga pictures. Syempre, meron siyang, kunyari yan yung pulley, tapos kung ganito ang ikot, of course, this will be your tight side tension. Pwede natin sabing F1 and F2. And since this is na mas malalim na topic ng tension sa design ng machine ng belt, kino-consider na natin si FC. So ano yung FC? So that was the centrifugal force. So search mo na lang kung ano yung meaning nun. Pero syempre since this is a rotating body, tapos involved pa si belt, nakaka-touch, of course there is a possibility of centrifugal force at napakahalaga sa topic na ito which is may sarili siyang formula and I will discuss this later. So Belt tension ratio, madali lang ng tandaan. So sa shop natin, we all know that F1 over F2 is equal to E F theta. So dahil concern mo is may centrifugal force, syempre, babawasan mo lang yung both numerator and denominator ng centrifugal force. So that will do to your belt tension ratio. Okay? So sa ang formula naman ng centrifugal force represented by FC is equal to 12 rho BT V squared over 32.2. So ano nga ba itong mga parameters na to? We all know that FC is equal to mass times the normal acceleration. So parang diyan dinerive yun. That's why makakita ka rin ng density and other parameters. So isa-isahin natin ano nga ba yung mga yan. So itong rho, which is the density of the belt material. So sa formula na yan, ang density mo dapat laging naka-pounds per cubic inch. So there are two types naman ng belt material na basically ginagamit, which is the rubber, and the leather. So ito, minsan di ginibigay sa problem kasi constant na. So I will give here. So sa rubber, ang density niya is 0.045 pounds per cubic inch. And the leather uses 0.035 pounds per cubic inches. And ang basic talagang ginagamit dyan at commonly ginagamit is yung leather, which is 0.035 pounds per cubic inches. So kailangan nang ipapasok mo dito, ano dito guys, na density is in pounds per cubic inches. Pounds per cubic inches. And how about this B and T? So B represents the belt width. So kailangan guys nasa inches siya na unit pag pinasok mo dyan. And of course, this small t represents the belt thickness as in inches then. So kung ito yung, dito na lang. So kung ito yung belt, ayan. Ayan. Of course, yan yung cross-section niya and that was the belt width and of course, ito din yung thickness kasi yung area na yan or cross-sectional area ang sumasalo ng puwersa mo. So kunyari, andyan yung F1. And this is your F1. Of course, this cross-sectional area, yan yung sumasalo ng force na F1. So that will become B and T. That represents belt width and belt thickness. That should be in inches pareho pag pinasok mo dito. Okay? So we have also the BS squared. So ano ba yung BS na yan? So that was the velocity. Is equal to pi dn. Kagaya ng diniscuss kanina. At kaya siya S kasi kailangan pag pinasok mo siya sa formula, dapat naka-feet per second siya. Yan na-explain yung 12 tsaka 32.2 kasi this whole formula is an English unit kasi mas madugo ang metric pag inisa-isa. That's why it is already derived. Basta sundin mo lang na yung density mo dapat nasa pounds per cubic inches. Yung BNT mo should be in inch. And of course, this BS or velocity should be in feet per second. Tapos square mo na lang. Then 12 over 32.2, the final answer, your centrifugal force is in pounds. Ngayon, kung tinatanong is kilograms, just use this set of formulas first para makakuha ka ng pounds na unit. Then, tsaka mo na i-convert sa kilograms. And syempre, meron din tayong tensile stress in the belt. Sakto, ito na yung drawing. So, ST or the tensile stress is equal to F1 over BT and also equal to design stress. Meaning kapag hinahanap yung tensile stress ni belt, you should find the amount of this F1. Given naman lagi yung B tsaka T, makukuha mo na yung tensile stress. Of course, the maximum force na may encounter natin sa buong topic ng belt should be F1. Kasi siya yung tight side tension. And syempre, numerically, lagi mas maliit si FC sa F1 at mas maliit lagi si FC sa F2. Hindi pwedeng lumaki sa FC sa F2. So numerically, dapat F1 is greater than F2 and F2 is greater than FC. And again, kapag walang centrifugal force, FC is equals to 0. So your belt tension ratio will be back to F1 over F2 is equal to EF theta. Okay? So para naman sa design stress, minsan kasi may mga given na cases na nakalagay cemented joint yung uri ng belt, wire lace, metal hooks. So for leather belt only, our design stress is equal to 400 times the joint efficiency. So we have the three types of joint efficiency, which is the 1.88 and 0.35. So that was for cemented, wire lace joints, and metal hooks, respectively. And syempre, may torque kanina, may force din. So, papasok yung walang kamatayang power. And that is equal to the difference of the F1 and F2 or tinatawag na net belt pull times the velocity of the belt. We all know that the power is equal to torque times radius. Torque times the RPM, the speed ng mga nakakaraang topic. And we all know that torque is equal to force times radius or force times diameter over 2. And that will do with the power is equal to force times diameter over 2 times the speed. Okay, and we all know that velocity is equal to pi dn, so that n is equal to velocity over pi d. So parang mangyayari, power mo is force times diameter over 2 times velocity over pi d. Siyempre, constant na yung dalawa, saka mo na yung pansinin, this d will be eliminated, doon nakuha yung power is equal to force times velocity. So that will be the velocity of the belt, and this F, ang tinutukoy niya is net belt pull or the net force, which is the difference of the two tensions, the tight side and the loose side. And how about naman sa unit analysis? So, sabihin na natin sa metric muna. So, ang force natin is in kilonewton. And of course, ang velocity ng belt nasa meters per second, and that will be kilojoules per second or kilowatts. So, that is the unit of the power. And syempre sa English naman, and that will be pounds. Sabihin natin feet per second. Ayan. So that will become in HP. Kasi merong 550 pound per feet per second sa isang horsepower. So yan. Yan na yung horsepower. So pagdating naman sa power transmitted by belt, mas madaling mag unit analysis kapag metric. At kapag hinahanap mo yung horsepower, pwede mo naman ipadaan sa kilowatts muna. And then punta horsepower. Or kapag kabisado mo naman yung mga conversions, so why not straight to the point for the horsepower? And we have this medyo mahabang formula that will be the general belt formula. So dito muna tayo sa una. So net belt pull, kasi minsan tinatanong din yung net belt pull is equal to F1 minus FC times EF theta minus 1 over EF theta is equal to power over velocity of the belt. So that will explain to the power is equal to force times velocity. So force is equal to power over velocity. So that's why it is the net belt pull is equal to power over the velocity. And syempre equal din siya sa F1 minus FC times EF theta minus 1 over EF theta. So kapag hinahanap yung net belt pull at nakita mo na yung F1, so si F1 pwede mo makuha sa SD is equal to F1 over BT kasi nga in order to get this maximum tension kapag given ito, use the design stress or the tensile stress. So sa FC, of course, kunin mo sa 12 rho BTBS squared over 32.2. And of course, itong EF theta, lagi naman given si coefficient of friction. At si angle theta ay pwede mong makuha based sa formula kanina na 180 minus 2 alpha. So don't use the 180 minus 2 alpha, just always use an angle of contact that is smaller, and that will be the 180 minus 2 alpha. Pwera na lang of course kung given is closed belt, pero lagi namang approach ay open belt arrangement. So use this 180 minus 2 alpha in getting this theta. And of course, this should be in radians. So makikita natin mamaya sa problem solving paano siya i-solve. And of course, this is power over V belt, which is kukunin natin ulit sa pamamagitan ng English unit analysis. Again, this is your net belt pull, and it is equal to, kapag given si belt thickness and belt width, so use this BT. So dapat nasa inches siya pareho. And obviously, nakuha yan dito. Kasi ang F1 yung nasa unahan mo. So para siyang F1 is equal to SD multiplied by BT. So ganyan yan. Tapos obviously FC, dito nakuha yan. 12 rho BS squared over 32.2. Siyempre may BT rin yan dito. So pinactor out na dun sa labas. Again, so yung density mo kailangan is pounds per cubic inch. And of course, this velocity should be in feet per second. And of course, this design stress should be in PSI, not kilopascal, PSI. That was pounds per square inch. And of course, multiply mo itong EF theta minus 1 over EF theta is equal to power over velocity. Ito, syempre, feet per second pa rin. Kagaya naman yung nandito. Is equal to power over BS times 550. Kagaya yung sinabi ko kanina, 550 foot-pound per second is equal to 1 horsepower. So, diyan nagmula yon. So, sundin mo lang daw itong mga units na to ay makakuha ka ng power in horsepower. And, syempre, kailangan i-divide mo siya ng BS na in feet per second. Syempre, involve mo rin si 550. So, that will do for the general belt formula. Hindi mo to maintindihan agad o babalikan kung walang problem solving. So let us do the problem solving. Okay, so determine the length of an open belt drive to connect 6 cm and 12 cm diameter pulleys at a center distance of 72 cm. So we have a formula for the open belt. Sabi, determine the length. So that was LB is equal to pi over 2 multiplied by the sum of the two diameters of the pulley plus twice mo yung center distance plus square mo yung difference ng two diameters, of course, all over 4 of center distance. And it is a direct substitution problem. So pi over 2 multiplied by the sum of the two pulleys, which is 6 and 12. So that was 6 plus 12. So centimeters both. Tama naman yung nasa choices, that will centimeter. So no more conversion required. Plus twice daw ng center distance, which is, sabi, 72. And D2 is 12. D1 mo is 6 squared plus 4 times 72. So the length of belt is, ay, may nangangampanya na naman. Linggong-linggo meron, no? So that the length of belt is pi over 2 times 18 kasi 6 plus 12 plus 144 kasi 2 times 72. So 12 minus 6, that was 6 squared, that was 36 plus 4 times 72 sa ilalim, and the answer is 172.4 centimeter. So obviously the answer is letter D. So sa second question, two pulleys 80 centimeter apart. So that was the center distance, carries a belt in a cross belt, sabi, arrangement. If the pulley diameters are 40 and 15 centimeters, what is the length of the belt required? As I said earlier, if you memorize the length of belt of the open, so madali na sa close. So magiging formula of the close is pi over 2 again times D1 plus D2 plus twice ng center distance plus ito ay magiging sum na, not difference. Kasi obviously the length of belt of a close arrangement is always larger than the open belt. Basta given ang same diameters ng pulley, and syempre same amount of the center distance. So dito lang sila magkakaparehas sa second term, first and second, and this third dyan na magkakatalo. Pero medyo maliit lang naman yung value na yan kasi malaki yung dinidivide mo rito eh. So that will do for the analysis, numerical analysis. So that will become pi over 2 times D1 and D2, which is 40 and 15 cm. Sakto ang multiple choice says ay centimeter in unit. No more conversion needed. Plus twice ng center distance, which is 80. Be careful dito guys kasi baka minsan may gantong magkasunod na tanong sa board at malagay mo is 72 yung center distance kasi naka 72 ka dito. So mag-inam pa rin na ilagay mo isa-isa yung given. Pero sa akin kasi sometimes ni isa-isa yung given, sometimes ni diretso ko na. So sinasabi ko naman saan galing yung mga sinusulat ko, no. So dito na tayo sa third term. So that was the sum of the two diameters, which is square mo din yun. Tapos 4 times mo raw ng center distance. So salpak sa calcu. So that will become 40 plus 15 times pi divide 2 plus 160 plus 55 squared over 320. So the length of the belt is 255.85 cm and wala ditong may decimal. Of course, this will be automatic converted to its nearest ones digit. So that was 256 cm. So obviously, the answer is the letter C. Okay, for the third question, a 10 inches diameter pulley is belt driven with a net torque of 250 foot-pounds. The ratio of tensions in the tight and loose sides of the belt is 4:1. What is the maximum tension in the belt? So we are looking for the maximum tension, which is, I said earlier, that is always the F1. Hindi natin siya mahuli kasi wala tayong involved na design stress or belt thickness or width. So we should use that belt tension ratio. And ito yung sinasabi ko guys na pag walang sinabing centrifugal tension, of course, just make it 0. So babalik lang sa dating formula na F1 over F2 is equal to EF theta. Okay, so ang sabi, the ratio of tensions in the tight, of course, ito lagi yung tight. And of course, F2 is laging loose side. So ang sabi, F1 over F2 daw is equal to 4:1. Sabi. Pero pwede nating sabihin na F1 is equal to 4F2. So our equation 1. So paano natin makukuha sa F2 para makakuha ng F1? We all know na meron tayong given na net torque of 250 foot-pounds. Meron din tayong 10 inches diameter na given. And we all know that F1 minus F2 is equal to 2T over D. So parang dinerive lang siya guys. At torque is equal to force times radius. Force times diameter over 2. So magiging force is equal to 2 torque over D. So this is your net belt pull. So that will become F1 minus F2 is equal to 2T over D. So ito siya. And sakto, F1 minus F2 is equal to 2 times what is our torque? That is 250 pounds. 250 foot-pounds. And I need to multiply it by 12 in order for it to become inches pounds kasi ang di-divide nating diameter is 10 inches. So, ibig sabihin ng F1 minus F2 natin is in pounds. So, that will become 2 times 250 times 12 divide 10. So, that was 600. So, ibig sabihin ang difference daw nila is 600. So, that will do for the equation 2. And pwede nating salpak si F1 dito. So, that will become 4. F2 minus F2 is equal to 300. So, ang F2 natin is magiging 3F2 is equal to 600. So, F2 is equal to 600 over 3. So that was 200 pounds. So meron na tayong F2, meaning we can get this F1, and F1 is equal to 4F2, which is 4 times 200, and that was 800 pounds. So the answer is obviously letter D, 800 pounds. Fourth question, a belt connects a 10 centimeter diameter pulley. Underline ko na yung mga given. Na 30 centimeter diameter pulley with a center distance of 50 cm. Determine the angle of contact of the smaller pulley. So kapag walang sinabi, guys, na arrangement, so assume lagi na open. So we all know that the smaller, yan na, drawing ko pa, wag na. Hindi na, drawing ko na eh. So that was the belt. So medyo makatotohanan yung drawing ko, no? Kasi may sag eh. So, may lundo. So this is your center distance. And of course, this is your angle of contact of the smaller pulley. So ito yung alpha mo, ito yung alpha mo. So this is your angle of contact, which is 180 degrees minus 2 alpha. And way back on the formulas, no, sa first slide or sa angle of contact nung ito yung angle of contact ng smaller pulley, may involved na alpha, which is alpha is equal to the arc sine of D2 minus D1 over 2C. So that will do it. So alpha is equal to arc sine. So ano ba yung diameter 2? Siyempre, dalawa lang naman given na diameter, 30 and 10. Siyempre, mas mataas yung second diameter. Minus 10 divided by 2 multiplied by the center distance, which is 50. And ingat lang din guys, kailangan pare-para sila ng units. Kapag nakita mong mm ito, divide mo agad sa cm. Or kung saan ka komportable yung pag-isahin lahat ng unit or pag pare-parehasin. So since this is cm, pare-parehas, so it will be all cancelled. Cm, ito cm, so cancelled. So our alpha is, so that will be the arc sine. So that is 11.54 degrees. At huwag ka masyado muna matuwa, engineer, dahil walang 11 degrees sa sagot kasi contact angle ang hinahanap. So that will be 180 minus twice ng 11.54. So that the angle of contact will be 180 minus twice ng 11.54. So that will be 156.92 degrees. And obviously the answer is letter D, 156.9 degrees. Okay. So dito na tayo sa second to the last question. The torque transmitted in a belt connected 300 mm diameter pulley is 400 Newton meters. Find the power driving the pulley if the belt speed is 20 meters per second. So we are looking for the power that drives the pulley given a velocity of 20 meters per second. So if we're looking for the power, we all know the formula is equal to the net belt pull times the velocity of the belt. So that was derived from the power is equal to force times velocity. So consider this basta pag-usapang belt, the net belt pull, and that the difference of the tight side and the loose side tension. So isa-isayin natin. So CB, meron na siyang 20 meters per second. Ang hinahanap na lang natin is itong net belt pull. So saan natin nahanapin? Meron tayong given na torque. Ang sabi, the torque transmitted in the belt is 400 Newton meter. And meron tayong diameter na 300 mm. And I will convert it to meters kasi meters ang mga given dito. So that will be 0.3 meters. And way back dun sa ibang question natin, guys, we all know that the net belt pull is equal also to the twice of the torque over diameter. And again, this is derived from the torque is equal to force times radius. It will become force times diameter over 2. So your F will become 2T over D. And consider this as the net belt pull kapag usapang belt. So that will become this equation, F1 minus F2 is equal to 2T over D. Pag nakuha natin yung value na to, pwede nating salpak dito. So F1 minus F2 is equal to 2T over D. That will become twice ng torque, which is 400 Newton meters divided by diameter na naka 0.3 meters din. So, cancel na si meters. Mukhang letter P ito, baguhin natin. So, F1 minus F2 is equal to twice ng 400, divide mo ng 0.3. So, that was 2,666.67 newtons. Pwede natin kabit doon. So, that will become power is equal to net belt pull 2,666.67 newtons times the velocity of 20 meters per second. And we all know that Newton times meters per second will give you a joules per second or watts. So 2,666.67 times 20. So that was 53,333.33 watts. And we all know that in every 1 kilowatt, there is 1,000 watts. So just divide this answer by 1,000 and that will give you 53.33 kilowatts. So obviously, ang sagot na naman ay letter D. Okay, so go for the last question tayo, guys. Medyo mahaba ito, no? Ngalan tayo konti. Again, a leather belt is 250 millimeter wide and 8 millimeter thick. It is used to connect a 400 millimeter diameter cast iron driving pulley to another cast iron driven pulley 900 millimeters in diameter. The coefficient of friction is 0.28 and the mass of belt is 1.9 kilograms. Using a center distance of 5 meters and maximum tensile stress of the belt is 1,400 kilopascal and the belt velocity of 20 meters per second, calculate the maximum power that can be transmitted. So the question is looking for the maximum power transmitted. And obviously, guys, there are full given. There are many given parameters that will be used, and obviously we're going to get the service of the general belt formula in order to get the power, which is equal to F1 minus F2 or net belt full is equal to BT times SD minus 12 rho BS squared over 32.2 multiplied by EF theta minus 1 over EF theta, then is equal to power over velocity multiplied by 550. So isa-isayin natin kung saan mahanap yung mga yan. So ang sabi ko kanina, ang BNT should be in inches. So hanapin muna natin kung may belt width tsaka belt thickness. So ang sabi kanina dito, a leather belt is 250 millimeter wide and 8 millimeter thick. So pwede natin sabihin na B is 250 mm. Yan, para maintindihan yung sulat. So thickness is 8 mm and it should be converted to inches. So that will become 250. Divide mo ng 25.4 kasi in every inch there is 25.4 mm. So that will become 9.84 inches and 8 divided by 25.4 that will become 0.315 inches. So solve na tayo dito sa BT. And syempre kailangan yung SD natin dito should be in PSI. So saan natin nahanapin yung design stress? Sabi, ang maximum tensile stress, so parehas lang yun sa design stress, of the belt is 1,400 kilopascals. So that is 1,400 kilopascal. And in every, sa 1 atmospheric pressure, there is a 101,325, 101 325 kilopascal. And of course, in every atmospheric pressure, there is 14.7 psi of amount. So that will be converted to PSI, 1,400 divided by 101.325 times 14.7, and that is 203.11 PSI. So solve na tong PSI here. So check na yan. And we should get the density and the velocity in feet per second. So density, walang given, pero ang sabi, may binigay ba? Wala, no? Pero ang sabi, leather belt. So use 0.035 as I said earlier. 0.035 pounds per cubic inch for leather. And ayan, di tama na siya rito. Natama na yung units, pounds per cubic inch. And of course, velocity in feet per second. Kailangan hanapin muna natin to. So we all know that the velocity is pi dn. So hanap muna tayo ng diameter. Sabi, it is used to connect 400 mm diameter. So pwede natin sabihin siya as si D1. The cast iron driving pulley to another cast iron driven pulley 900 mm in diameter. So lagi lang naman dalawa given na diameter. So 900 mm. The coefficient of friction is 0.28. And the mass of belt is 1.9 kilogram. Using a center distance of 5 meters, a maximum tensile stress of the belt is 1,400 kilopascal and belt velocity of 20 meters per second. May given na palang velocity. So that will become 20 meters per second. So convert natin sa feet per second. So that was 20 times 3.28 kasi in every meters there's 3.28 feet. So that will become 65.6 feet per second. So, okay na tayo dito. So, okay na rin tayo dito. Makakuha natin power. Ang kulang na lang natin is EF theta or yung F and theta. Meron tayong given na F which is 0.28. Tapos, ang theta natin, of course, always use the smaller, which is 180 minus 2 alpha. So, ang alpha natin is, yun, dito na pala magamit yung dalawang diameter. So, that will become arc sine d2 minus d1 over 2c, which is ang alpha natin is arc sine ng dalawang diameter, which is 900 minus 400. No need to convert na rito. Divided by twice ng center distance, which is sabi 5 meters. So convert mo sa mm. So that was 5,000. So ang alpha natin is 900 minus 400 divided by 10,000. Arc sine nun. So that will become 2.87 degrees. Of course, our theta is 180 minus 2 alpha. So that was 174.26 degrees. It should be converted into radians. So that is in every 180 degrees, there is pi radians. So that is 3.04 radians. So ibig sabihin ng EF theta natin is E raised to 0.28 multiplied by 3.04 is equal to that was times 0.28. E raised mo doon. So that will become 2.34. So may 2.34 na tayo dito. So everything is in right place at the right time. So, pasok na lang natin. Sana kasya pa. So, ibig sabihin, huwag ko nasulat ng F1 minus F2 guys. Dito na magsimula. So, BT 9.84 9.84 times 0.315 times SD, which is 203.11 minus 12 times 0.035 times BS squared. So, ang BS natin in feet per second ay 65.6 squared divided by 32.2 times EF theta, which is 2.34 minus 1. So, sabihin natin 1.34 na lang siya. Divided by 2.34 is equal to power multiplied by 550 divided by BS, which is 65.6. So, ang power natin is in HP. Tapos, ang choices ay nasa kilowatts. So, convert na lang natin later. So, ang haba ng solution, no? Tapos kilowatts pala yung nasa units. So, kung ang final solution mo is mali, tapos ko-convert mo pa, then mali na rin. So, be careful talaga. So, that will equal to 9.84 times 0.315 times 203.11. Unahin mo muna yung nasa bracket. 203.11 minus 12 times 0.035 times 65.6 squared times 30 divided by 32.2 times natin na 9.84 times 0.315 times 1.34 divided by 2.34 times 65.6 divided by 550. So the answer is 31.12 horsepower. And 1 HP is equal to 0.746 kilowatts. So the answer is 23.2 kilowatts. So the nearest answer is ito, yan, letter B, 23.4 kilowatts. So nagkatalo sa decimal, bakit? Kasi ginamit natin agad na constant kasi letter ang given, which is 0.035 pounds per cubic inch. Pero pwede rin natin gamitin yung density is equal to mass over volume. Kaya may given na 1.9 kilograms kanina dyan. And of course, meron din namang volume na pwedeng gamitin. Yung length niya ng belt times the belt thickness and the belt width. So parang kinuha mo lang yung rectangular ano niya, yung volume. Ayan. So thickness mo yan, ito yung width mo, ito yung length mo. So of course, mass over volume will do on the density. Pero yung value mo kasi niyan is magkakalapit lang talaga dito. Pero maganda nito kasi board exam to, so you can use this or kapag rubber ang given, 0.045. Pero syempre kapag talagang actual designing na, you should use this one. Lalo na may given na timbang. Kasi may limits ka diyang susundin. Pero anyway, nakuha natin yung sagot which is 23 point something kilowatts. And that will do it for the topic of belt. Napahabang ating usapan. Naway may natutunan kayo at may naiambag ako sa inyong pagre-review. And of course, I'm open to questions. Just comment do sa comment section or PM me on Facebook page. Please visit nga pala our Facebook page that is written on the link. And of course, please share this video and please subscribe. Thank you for listening, guys. See you on our next video. This is Engineer HB. Bye-bye.